All right, hello, my wonderful students. This is part two of our first foldable. So we're gonna do the same thing. We're gonna find our theta. Well, given our theta, we're gonna find our alpha and our beta, and then we're gonna convert them to from on the first one from radians to degrees, and on this one from degrees to radians. Okay, so I'm going to get started. So we see we have a negative 8 pi over 3. So I know I'm going to cut my section from here to pi into 3 sections in order to do that. So I'm going to go ahead and count negative 8. So negative is going to go this way, because positive goes this way. All right, so we're going to go ahead and start here. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be our negative, so our theta is going to be our negative 8 pi over 3. All right, so now let's go ahead and do our alpha. Our alpha is actually the line that's here, the angle that's here. I know the color looks very similar, but this one's a little darker. It's green. This one's blue. So our theta is here. And if we would have kept counting, this actually would have took us to 9 over 3 theta. So this would actually just give us an extra equals pi over 3, which we already know from the last video that this is actually 60 degrees, but we'll still do it just so that we have the practice. All right, so now we got to look for our beta. So we technically could just go from here to here because it's a different route, because if you know theta went all the way around here and stopped, so it actually crossed this part here in the first time around. So we can actually just go here and right there. And then so our beta is going to equal, which was here. So if we remember all the way around, we went 2 more pi over 3s. So this is going to be our negative 2 pi over 3. Okay. We could have also went around this way and did this here. So yeah, we could have went around there and found a different beta, but this is the shortest beta we can find, which ends up being our negative pi over 3. So now we have our theta, alpha, and beta. So now we got to convert each of them to degrees. So we're going to go ahead and just use the top one here, since once again we squished ourselves down here. So we're going to multiply the top by 180 over theta, over pi. And then we're going to see once again that we can reduce the pi's. And then we're left with a very similar situation where we have 180 over 3. So we know that 18 divided by 3 is 6, and then we could add the 0, so make it 60. So this is actually going to end up being negative 8 times 60. And we know that, excuse me, we know that 8 times 6 is actually 48, because 8 times 5 is 40, plus another 8, which would be the 6th 8, would be 48, and this is negative. So this is going to be at negative 480 degrees. All right, let's go to our alpha. Well, like I said before, our alpha is going to be the same as it was up here, because it's also pi over 3. And you notice that alpha is actually going to be very similar to a lot, because since it's always a primary angle, it's never negative. It always ends up being like a positive angle no matter where we are. It's always going to be between pi over 2 and 0. So it's going to be very common to have multiple of the same alphas. All right, so we're going to have our pi over 3 times our 180 over pi to find our degrees. Once again, we're going to reduce these, and we get a similar situation. We get 180 divided by 3, which gives us our 60 degrees for our alpha. So our alpha is also going to equal 60 degrees. Now we're going to go ahead and go to our beta. Oh, I just realized that our beta here is the same as our beta here. So this is two very similar problems, even though they were in different quadrants. This one here is in quadrant 3, where the other one was, actually they're both in quadrant 3. So, okay. All right. So let's go ahead and do that. So once again, we have we'll do it up here. Ooh, excuse me. Sorry about that. So So we have our beta, which is negative 2 pi over 3, multiplied by 180 over pi. We can already see that our pi's are going to reduce, leaving us with 180 divided by 3, which is 60. So it's going to be negative 2 times our 60, which is going to equal negative 120 degrees. So that's going to be our second beta, negative 120 degrees. And I'll go ahead and box this up again so you guys can see where it is. All right, now let's go ahead and go to degrees. Degrees is a little different than radians was, but it's very similar in the fact that we're going to count the same way around, but instead of counting in pi, we're going to count in degrees. And we know if this was a triangle, like if I were to draw a little mark here, and we saw this right here, this would actually be 90 degrees. So we know that from here to here is 90, here to here is 90, here to here is 90, and here to here is 90. So it's 90 times 4, which gives us 360. That goes all the way around to a circle. All right, so we're going to go ahead and find our negative 210. So once again, negative goes clockwise, not counterclockwise goes positive, but negative here goes clockwise. So we're going to go ahead and count. We're going to count our 90, then our 180, and then we got to figure out how much we need to go. So I know I went 180 already, so I'm just going to get my 210, and I'm going to subtract 180, because if I already went 180, I need to know how much more I need to go. So we're going to go ahead and subtract that. I get 0, carry the 1, and I get 3, and then 1 minus 1, 0. So I know I need to go 30 degrees more, which is about right there. It doesn't have to be exact, but it has to be pretty close to where you got to be. So that's going to be our theta. So I know our theta is equal to negative 210, because we just did that. We did 90 plus 90, which is 180, plus 30, which is 210. All right, now we got to find our alpha. Kind of already found our alpha because we already did the work. We have our 210 here, and we know this is 180, and we did our subtraction already here, 210 minus 180, to find what this degree would be here, which is our alpha. So our alpha is actually going to equal 30 degrees. So I know Mr. Payana, but it's going negative. But you got to remember that alpha is always positive no matter what. Okay, so even though it's going negative this way, it doesn't matter. This is still a positive angle of alpha. Okay? All right, and now we're going to find our beta. So once again, like I said, it's easiest to just go around this way to target our beta. So I'm just going to go from here, 0, and I'm going to go all the way over to here. Oh, my red pen's going out now. No, it's not. Okay. And I'm also going to dot the line to show that it finishes there. Oh, I didn't do that here, but let me dot this line too. Over here to show that it actually finished here. Okay, we'll go back to this one. So we see that our beta actually finished there. So I'm going to write beta here. Beta is equal to. So now we got to figure out what it was there. So we have two options. You can get the original angle and subtract it by this, which is 210. And get 360, which is all the way around, subtracted by 210. Or we know this is from here to here is 180, and we know this is 30, and we can do 180 subtracted by 30, which is here because of the alpha. But I'm just gonna make it easier for myself because I can just use the original here. That's what we're using. So I'm gonna get our 360, which is the degrees all the way around, and I'm gonna subtract what we used to find our theta, which is 210. 0, 5, and then 1. So I know my beta is equal to 150 degrees. And I found that by doing the full way around minus what I already used here to find our beta. Okay? So now we have all our measurements in degrees, and we got to change them to radians. So I'm going to start with our alpha. So instead of multiplying by 180 over pi, we're actually going to multiply by pi over 180. So we have our negative 210. We're going to multiply this by pi over 180. So this is going to be a little bit more difficult than the other one just because we have, I'm not going to use a calculator. I'm going to show you the way it works. So I'm going to rewrite this as together as negative 210 pi over 180. Just to show you that I can go like this and reduce the zeros. So zeros are already out, so now we just have our negative 21 and our positive 18 and our pi. So I'm going to divide the top by 3 and divide the bottom by 3. So pi we can just leave as pi. So we're just going to go ahead and put equals here and leave pi on the end. And I know that negative 21 divided by 3 is negative 7. And 18 divided by 3 is 6. Ooh. Got some voodoo magic over here. Something just fell behind me. Nothing touched it. It's kind of creepy. I'm in my classroom, by the way, guys. Ta-da, thumbs up. Where's it? All right, so now we go ahead and do our alpha. So this is our conversion of theta. So I'm going to go ahead and box this up here because that's what our theta was. We're going to do our alpha. Alpha squished over here, so I'm going to go ahead and do the work for alpha over here. So we have our alpha is equal to 30 degrees, but we're going to actually multiply 30. Excuse me, we're going to multiply 30 by pi over 180 degrees. So we can see here we can reduce these zeros again, and then we have 3 over 18. If you can see, we can actually divide each of these by 3 again. So we're going to divide by 3, and we're going to get that 3 divided by 3 is 1, so it just leaves us with pi over 18 divided by 3, 6. And that gives us our pi over 6, which we know is 30 degrees because we can look at our unit circle and see that. All right, last but not least, we have our beta, which is our positive 150. So we're going to get our 150. We're going to multiply it by our pi over 180. And same thing again, I'm just going to extend the line over to show that it's like that. I'm going to get rid of our zeros and leave us with 15 over 18. Divide, 3 is a common deal over here, so I'm just going to change this over here. I'm going to have 15 pi over 18. Divide by 3. Divide by 3, and this is going to equal 15 divided by 3 is 5, but it's going to be 5 pi over 18 divided by 3 is going to be 6. And that's converting everything from radians to degrees.